Alright, so we're going to go ahead and go over your mobile project, give you an idea what you have going on. So, if you don't know what a mobile is, it's one of these things, which is on the right hand side here, right? So, like a generic basic one would be just a couple bars hanging from strings with objects hanging off of those bars. You might see more complex ones where there might be something hanging from another object. So this is supposed to be something that, put someone to sleep. Maybe down here, instead of there being a bar, there's like a crescent moon or something. And hanging off of that crescent moon would be another object on each side of it. Okay, but we're not going to get that complicated right now, because when you're dealing with something like that, then you've got to consider, where the center of mass is for that object and everything. But if you can keep your bars a fairly consistent or uniform shape and mass and everything, you don't have to worry about finding the center of mass for that thing and then making things even more complicated. So what you really want to do is make sure that you are pretty careful about what you're picking out for these bars. I've had teams or groups in the past that have used golf clubs for this, which worked fine. But what they had to consider is they had to consider the club head as being an object. Right? So if this top bar here was indeed, say, a golf club, right? This pivot point located here would have a mass acting at this point, and then another one which would be acting here. So this counterclockwise torque on the left-hand side would have to be the torque of this entire system down here of M1 and M2 and the torque of the club head. So if you want to do something like that, that's fine. Just make sure that you include that in your calculation. So the setup we're going to do is just a singular bar across the top with two bars suspended from it, and then two objects, or at least two objects suspended from each one of those bars. Normally we'd get more complicated with this if we're doing this in class. Since we're doing this virtually, we're going to try and keep it a little simpler. Now, to figure one of these things out, you need to make sure that you are in static equilibrium at each one of these points. You need to make sure that you're at a static equilibrium here, here, and there. Now, this static equilibrium here, we'll call these points 1, 2, and 3. Here at point 1, you need to make sure that your torque, like your net torque, right, is 0. Well, you know that your torque here on this side, torque clockwise, this would be the force times the distance, right? So that would be M2's mass times G, because we're dealing with the force of gravity here, times this distance to where it's tied up, where it's tied to the bar. Okay. Now, on this side, your torque counterclockwise is again Fd, which would be M1G times its distance from the pivot point. Now, depending on what masses you have here, there's different ways you can go about doing this. You can look at the combinations of masses and then think about, okay, how much should D1 be, or this distance over here, we'll call these D1, D2, so try and make things a little easier. If D or M2 is like twice the mass of M1, well, we know D2 is probably going to be about half of whatever D1 is in order to have the same net torque. So you can either set these object masses and then piddle with these distances to try and get your net torques to be 0, or you can choose one mass and its distance and then go about finding what would the other object have to be in order to make this all balanced, or where does it have to go to make it all balanced. But the first thing you want to do is get this pivot point, this point 1, balance based on what you have down here. Then you're going to go to the other side of your mobile for pivot point 2. You're going to be working with M3 and M4 here, and it's going to be the same set of equations. You still need your net torque to be 0. which means that the counterclockwise again is going to be m3g times the distance that it is from the pivot. Call that d3. And then the torque over here that's clockwise is going to have to be m4 d4, its distance from the pivot. Get that balanced out for 2. From there, you're going to go up to the very top of your mobile. Now, with your mobile, you're going to need to make sure that the torque in this direction, which is another d value, we'll call this d5, and we'll call this one over here d6. You need, again, net torque to be 0. So on this side, counterclockwise is going to be the torque generated by this entire M1, M2 system. So that's going to need to be FD again, but your force here is M1, M2, and whatever bar you have, right, times whatever D5 is. So that's going to be your torque counterclockwise. On this side, your torque clockwise is going to be FD, with the force this time being M3 plus, I forgot the G on this side, GD5, there we go, M3 plus M4 plus whatever that bar is, times G, and then D6. So what you need to do for this lab is you need to pick out 4 items, got to pick out your bars, sticks, whatever you're using to happen to make these rods, your material, whatever you're tying it up with, right, your cable or something, and then draw up your design, your basic design, what you think it's going to look like. Work your way through these calculations. Show you balancing the torques on the side over here at pivot point 1. Show you balancing your torques on pivot point 2. And then show the calculations for 3. Once you've shown that you've theoretically solved for all of this, try putting it together. Go ahead and tie it all up, get it balanced, and take a picture showing your final result. Now, odds are, when you go to actually put this whole thing together, the measurements for D1, D2, and so on aren't going to be exact. And the reason that is because if you're not using something that is exactly uniform, then you're going to have some distribution of mass on one side or the other. I mean, technically, even if it's uniform, if D1 and D2 aren't very similar, there's going to be more mass on the side that has the longer lever arm, the longer distance to the pivot point. Okay, so it's going to need to be shifted just a little bit. As long as you're not drastically off from what you were calculating, then you're going to be fine. And like I said before, in the Google Classroom, once you're done with that, take that picture, submit something showing all of these calculations and your diagram and everything, put all of that into some kind of a Google slide or a doc, and turn that in as your final assignment. This is going to be a 2-week project. It's going to take some time. So looking for the due date basically to be before break. So yeah, that class right before break will make that the due date. We'll see how people are doing over the course of the next couple of weeks and see if maybe we just roll this right into Christmas break. So get it turned in before we go on break, and then we just say that's good enough. Okay? Now, something that, go ahead and save this so you have a copy of that. Something you're also going to need to do is you're going to need to know the mass of your objects. And if you have a way to measure the weight of them, then that's going to be, you know, a lot easier. So if you have like a scale that's, you know, rather sensitive, that would be a good option. If you happen to have, say, a kitchen scale or kitchen balance, that would work. If you don't, then you're going to have to figure out a way to find the mass. And you already know really how to do that based on the lab that you just did. So that balancing act lab, you were figuring out ways to find the mass of an unknown object based on the known value of something else, right? So what you can do is take one of the bars. Hopefully it's going to be something that's rather uniform. If you have like a meter stick or a ruler, a broomstick, but if you're using a broomstick, make sure you unscrew the broom head to use that, so that way you're not having to add the additional mass of the like the bristle part of the broom. And what you're going to do is you're going to, well, first you can start off with placing the item on some kind of a pivot point, right? So, I mean, you're obviously not going to have some kind of a block, but find something fairly pointed that you can like rest it across, maybe like the top of a chair, or top of like a pop can or something, even like set one on its side. And then you're going to place your object on one side. So let's say we're dealing with M1, right? You're going to place your object M1 on one side of the item. You might have to tie it off to it. You might, if it's something like a 2x4 or something, or a wooden plank, you can just lay it on top. If you're using the broomstick method, you might have to use a piece of string to tie it to the end of the stick. And then you're going to place something over here, right, that's known. So find something around that could be usable with M1. Like say M1 is something, you know, like a baseball or a softball or whatever. You can use, say, for your known value, something like a pop can or a carton of some kind of a, I don't know, carton of orange juice, milk, or whatever. Something that over here you'd be able to know what the mass of the thing is. And if it's dealing with some kind of a liquid, you can use you know, like density equations to figure out the mass of that liquid. Or most of them happen to say the fluid ounces on there. But use some kind of a balance setup like this to figure out what your unknown mass is. You, again, are going to try and find a balancing point, so you're going to be looking for a net torque equivalent to 0. So you're going to have to calculate what this counterclockwise torque is, m1g times the distance, and then you're going to have to figure out the clockwise torque, so m of known value times g of d2, and yeah, just play with this until you can find the mass of all the objects, unless they're, of course, something you can look up. So if you have a baseball, you can just look up the mass of a baseball, right? So like most objects, like generic things, you're going to be able to look those up. If not, you don't have that option to use the kitchen scale or a balance or whatever, go this route. If you are going this route and you need some assistance with figuring out these values, well, stop in during office hours, and we can look at your setup and work through how to calculate the values for all of the different masses, because that's going to be really important when it comes to this lab is making sure those mass values are as accurate as you can get them, just to make things a lot easier on you. Okay, so go ahead. You have, like I said, you have a couple weeks for this one. Make sure not to put it off. You probably want to spend week 1 just making sure you have your items all picked out, having your masses figured out for all of your things, and then maybe even start to do a preliminary sketch. And then week 2, you can have that as your calculation phase, and maybe like a basic mock-up. And then, if needed, work into week 3 with getting everything fine-tuned. And then, of course, prepping your submission. All right, so that's it for the next little while. But just make sure you keep checking in. Each day we have class, just for attendance reasons and everything. And good luck with it.